Okay guys, today we're finishing out section 5.6. So we're calling this 5.6b, and we're working on applications of the discriminant. Now in your notes you should be able to see that the discriminant is just a piece of that quadratic formula. It's just the b squared minus 4ac. And then in our notes as well, we wrote that this tells us not what the solutions are, but how many there are, and the type of solutions that you have. Okay, and so we have three options. If the discriminant, whatever we get for here, is greater than 0, then you'll have two real solutions. If it's equal to 0, there's one real solution. And if it's less than 0, there's two imaginary solutions. Okay, all right, now again, you're not finding those solutions. You're just determining how many and the type. So if you take a look at example 4, example 4a gives us x squared minus 6x plus 10 equals 0. And so we need to figure out what our a, b, and c are first. Remember, this is a, b, and c. So a is 1, b is negative 6, and c is 10. So now if we sub it into the discriminant formula, we'll have negative 6 squared minus 4 times 1 times 10. Notice I put this negative 6 in parentheses. Okay, because if you're a big calculator user and you don't put that negative 6 in parentheses, your calculator will not square it. And remember, anytime we square a negative, anytime we square any number, we should get a positive. So we get 36 there. Then we have 4 times 1 times 10, that's minus 40. And 36 minus 40 is negative 4. Now this number is my discriminant. Now if you look back at your notes, is that number greater than, equal to, or less than 0? Well, this number is less than 0. So that tells me that this equation right here will have two imaginary solutions. And that's all I have to do. There's my discriminant. There's what it tells me. Let's take a look at part B. Part B says x squared minus 6x plus 9. So this time, a is 1, b is negative 6, and c is 9. Sub them into your discriminant formula. Negative 6 squared minus 4 times 1 times 9. This would be 36 minus 4 times 1 times 9 is 36. That gives me 0. This is my discriminant. Is that number greater than, equal to, or less than 0? It's equal to, so that tells me that this equation, if I would have solved it, would have given me one real solution. Okay, part C. Part C gives me x squared minus 6x plus 8. So a is 1, b is negative 6, c is 8. Subbing these into the discriminant formula, negative 6 squared minus 4 times 1 times 8. That would give me 36 minus 4 times 1 is 4 times 8 is 32, which gives me 4. There's my discriminant. Now is this number greater than, equal to, or less than 0? It's greater than 0. So that tells me there are two real solutions. If I were to solve this equation, I would get two real solutions. Okay? So that part of it is easy. Now, taking a look at example 4 and those three equations, notice the only thing that changed was the C. Part A, see if I can get there. Part A had a C of 10. Part B had a C of 9, and part C had a C of 8. Notice how it moved my graph down, okay? If you think about that in your head, I had no solution, then I had one solution, then I had two real solutions. Well, remember from before that solutions are the same as x-intercepts. So meaning on that first one, when we had no solution, well, actually, sorry, we had two imaginary solutions. If it's an imaginary number, that means in the real world it doesn't exist. So that means if there are two imaginary solutions, and imaginary solutions truly don't exist in the real world, then the solutions or the x-intercepts, there wouldn't have been any. So this gives me no x-intercepts. Okay, taking that further, we know the graph of any quadratic equation looks like a parabola. If I were to draw a parabola and it can never touch the x-axis, it would have to be up here somewhere, okay, where it never touches this x-axis. So the second one had one real solution. You know solutions are the same as x-intercepts, so if it had one real solution, that means it has one x-intercept. And that means when I graph it, it can only touch the x-axis one time. So that means it has to look something like this. Or it could look like this, okay? Anything that only touches in one spot. That's one real solution. Okay? The last one then, of course, I'm going to turn my board here, would be if I had two real solutions. Well, if we have two real solutions, and solutions are the same as x-intercepts, that means I have two x-intercepts, meaning it crosses the x-axis in two places. So it could look like this. It crosses two times. It could look like this. It crosses two times, and so on and so forth. So you can tell the difference in the graphs as the solution changes. When it was no real solution, it never touched. When it was one real solution, it only touched one time. And then when it was two real solutions, it touched twice. Well, now they're going to want to know, okay, so then can you create an equation that will make all three of these? Can you change the C? Because remember, that's what was changing on A, B, and C of example 4. Can you change the C to make that move down? Okay. Well, let's just go back to that equation they gave us. X squared minus 6x plus C. So what this is saying is, what will C be so that I get two real, one real, and two imaginary? Okay, what could my numbers for C be? I start with one real, okay? So to get one real, what I have to do is I have to create a perfect square trinomial. Think about when we completed the square. We took the middle term, divided by 2, and we squared it. So in this case, that would be -3 squared or 9. So when C equals 9, I'll have one real solution. Okay, because that would create a perfect square trinomial, meaning when I factored that, it would look like this, equals something, equals 0, and my solution would be 3. Okay, you could also check it by checking your discriminant. If this was A, this was B, and this was C, and you put it into B squared minus 4AC, do I truly get one solution? And you should. Okay. So now I've got to figure out, okay, well, now that I know what one real solution C would be, how can I get two real or two imaginary? I just pick a number, okay? So if my C is 9, let's say I pick 10. Now, 10 is what in regards to 9? 10 is greater than 9. So I am picking a number when C is greater than 9. I'm testing 10. Okay, I'm going to actually find discriminant this time. A is 1, B is -6, C is 10. Let's find discriminant. So B squared minus 4AC. That gives me 36 minus 4 times 1 times 10 is 40, -4. If I get a discriminant of -4, that means there are two imaginary solutions. So that means any number greater than 9 is going to give me two imaginary solutions. Because when I tested 10, that's what I got. And that means anything above that will be that same way. So then I always make sure I'm right. Now I go the other way and think, okay, when C equals 9, it was one real solution. When C is greater than 9, it was two imaginary. So when C is less than 9, I should get two real solutions. But we've got to test and make sure that's right. So let's pick a number less than 9. I'm going to pick 0 just because that's easy. So A is 1, B is -6, C is 10. Oh, sorry, forgot. I'm testing 0. Now let's do B squared minus 4 times A times C. That would be 36 minus 4 times 1 times 0 is 0. That gives me a number greater than 0, which proves the two real solutions. Okay, so this, and this is my answer. Okay, now you guys have to do this on number 68 through 73. So let's look at 73. Okay, 73 gives us x squared minus 12x plus c equals 0. Okay, and they want us to find out when there are two real solutions, one real solution, and two imaginary solutions. So remember, I always start out with one real. He's my middle ground. I'm not even going to spell that out. I will when I find it. Now to find my one real solution, I have to complete the square like I did in section, what was that, 5. So I take this middle term, -12, divide it by 2, and square it. That gives me -6 squared, which would be 36. That tells me when C equals 36, there will be one real solution. That's one answer. Okay. Now I'm just going to pick a number. Okay. Let's pick 0 because he's an easy number to test. And 0 is what in regards to 36? It's when C is less than 36. So now let's put it in. A is 1, B is -12, C is 0. And I am testing to find the discriminant here. So I have B squared minus 4 times A times C. That gives me 144 minus 0, which gives me 144. And when I get a discriminant of 144, that is greater than 0, so that tells me that's two real solutions. That means any number less than 36 will give me two real solutions. We tested 0. 0 was less than 36, so that means any other number less than 36 would give me two real solutions. So that means if C equals 36 is one real, C less than 36 is 2 real, then C greater than 36 should be 2 imaginary. But I've got to test it, okay? So this time we need to test a number greater than 36. Let's test 37. Not a fun number to test, but we can still do it. A is 1, B is negative 12, and C is 37. So we have negative 12 squared minus 4 times A times C. This is going to give me 144 minus 148, which is negative 4. Because the discriminant is negative 4, it is less than 0. That tells me that there would be 2 imaginary solutions. So that means any number greater than 36 will give me 2 imaginary solutions. There's my final answer. Okay, so you're going to use that for that section. Now, the other part of this section on 294, page 294, working with goal 2, goes back and talks about, first off, object is dropped. We worked on object is dropped model in section 5.3. Now we're talking about object is thrown. What's the difference? Well, there's force behind it, okay? There's a difference between a feather being dropped from a building versus a bird soaring down to pick up its prey, okay? It has force behind it. That's called velocity as well, okay? A velocity is like a speed, but speed with direction. So meaning if that eagle is swooping down for its prey, that velocity is going to be negative. If that eagle is swooping up to land on the flagpole, then his velocity is positive. Regardless, they give us this equation, h equals negative 16t squared plus vt plus h sub 0. Remember, this is my hit height, this is my time, this is my velocity, and this is my initial height. All right, notice we didn't have velocity in the first one because it was falling. Okay, there was no velocity with it. So if you take a look at example 5, example 5 talks about a baton twirler that's tossing the baton into the air. So she is throwing it, she's not dropping it, she's throwing it into the air. Since she's tossing it up into the air, that would be a positive velocity. So let's remember that as we read it. It says the baton leaves the twirler's hand 6 feet above the ground and has an initial velocity of 45 feet per second. So right there we know that it left her hand at 6 feet and that its velocity is 45 feet per second. Then it says the twirler catches the baton when it falls back to a height of 5 feet. I know it's falling back down, but she initially threw it. Okay, so it is a fall, or it is a thrown object model. But where is its hit height? Where is she catching it? At 5 feet. And it wants to know how long the baton is in the air. So it wants to know t. So we've got 5 equals negative 16t squared plus 45t plus 6. Now, this isn't saying what is the solution, or what does the solution look like, what type of solution. It wants to know how long did it take. Okay? Sorry guys, just a second, something came up on my computer. So for a quadratic equation, we have several methods of being able to solve this to be able to find what t is, most of which start by getting it equal to 0. And guys, since this section is about quadratic formula, I would use quadratic formula for this problem. So here's my A, here's my B, and here's my C. T equals negative 45 plus or minus the square root of 45 squared, there's my B squared, minus 4 times A is negative 16, C is 1, all over 2 times A, which is negative 16. Now we need to clean that up. Negative 45 plus or minus the square root of 45 squared is 2025. I should have known that. 4 times 16 times 1 is 64. 2 negatives make a positive. And that's all over negative 32. And I'm running out of room, so bear with me. This gives me negative 45 plus or minus the square root of 2089 over negative 32. Now, granted, guys, we could use tree method to break this down, but this is a real life situation, okay? I need a decimal answer. I need an actual answer. So I'm actually going to split this up, and I'm going to do negative 45 plus the square root of 2089 over negative 32. And then I'm going to do negative 45 minus the square root of 2089 over negative 32. And I'm going to decide which one of those is more realistic. Okay, well, let's use our calculator. Try to get where it's not so much of a glare. Okay, so I'm going to do negative 45 plus square root of 2089. I hit enter, and then I hit divided by negative 32. I get negative 0.02. Now I'm going to do the minus. Negative 45 minus square root of 2089 divided by negative 32. I get 2.83. Now let's talk about here what this problem was about. It wanted to know how long was the baton in the air. Can the baton be in the air for negative 0.02 seconds? No, it cannot. It is not a reasonable answer. 2.83 seconds is the only one that makes sense. Okay. All right. We've got some time here, so let's do number 16 as well. Notice the difference in the problems, guys. The first thing I did on this board was just discriminant. It was just finding types of solutions. Okay. Then I went on to talk about how the graph or the equation changes so that your solutions change. Now we're talking again about actually finding solutions like you did yesterday with quadratic formula. Okay? All right, so make sure you're definitely reading and checking to see what is it asking you. So let's take a look at number 16. It says, a basketball player passes the ball to a teammate who catches it 11 feet above the court, just above the rim of the basket, and slam dunks it through the hoop. Okay? This play is called an alley-oop. All right, well, if somebody is passing the ball to you, there is force behind it. So we immediately know that we're talking about object is thrown. They are throwing the ball. They are passing the ball. And it says, the second teammate catches it, so that's the hit height. This would be 11. Then it goes on to say the first player releases the ball 5 feet above the court. That's the initial height. That's where he passed it. That's where it started. With an initial velocity of 21 feet per second. Now, when you pass a ball, are you passing it up or are you passing it down? Well, look at where it started from. It started at 5 and it went to 11 feet. So he had to be throwing it up to a certain point. If you think about the alley-oop dunk, somebody passes it up to someone and then they catch it and slam it down. All right, so it is going up, so my velocity stays up. And it wants to know how long is the ball in the air before being caught, assuming it is caught as it rises. So we're trying to find t. Anytime I solve a quadratic equation, I have to get it set equal to 0. So subtract that 11 over. That'd give me minus 6. Here's my A, here's my B, here's my C. Remember, they want me to use quadratic formula because that's what this section is about. So t equals negative b plus or minus the square root of b squared minus 4 times a times c over 2a. Let's clean up under that radical. 21 squared is 441. 3 negatives is going to make a negative. And 4 times 16 times 6 is 384. That gives me negative 32 on the bottom. 441 minus 384 is 57. So I've got negative 21 plus or minus the square root of 57 over negative 32. Now remember, I could tree method this like we had to simplify radicals in section 5.3, okay, or that you had to do yesterday on your homework. But remember, this is a real life situation, guys, okay? So there's no sense in doing that. You need a decimal answer. So we need to do negative 21 plus square root of 57, all divided by negative 32. And then we need to do negative 21 minus square root of 57, all divided by negative 32. Let's do this on our calculator. So we have negative 21 plus square root of 57. I hit enter, and then divide by negative 32. So I get 0.42. Now I'm going to do the minus. So negative 21 minus square root of 57. Divided by negative 32 is 0.89. Okay, now I have two positive answers, which as you can tell was puzzling me for a second. Okay, but let's think about this, guys. These are the solutions, correct? And if you think about a quadratic equation, the graph of a quadratic equation looks like a parabola. In this case, a parabola opening down. So if this is my graph, and here's my two x-intercepts, my two solutions. This problem said, how long is the ball in the air before being caught, assuming it is caught as it rises? So if you think about the path of that ball, it's going up, going up, going up. Now it's coming back down, back down, back down. They're wanting the ball to be caught as it rises. That's this one here. So 0.42 is the only one that works. If you're catching it when it comes back down, that means you've caught the ball down, you're bringing it back up for the alley-oop. That's not what we want. We want the person and the ball to be going up at the same time so that they can dunk it together. So we had to think a little harder on that one. Okay, remember the ball is going up to a certain extent until it starts to come down. We want that person to catch it when it's going up. We want the solution when it's going up. So it would be 0.42 seconds, of course. Okay?